This program is a walkthrough of how to use the stack to iterate through the Windows directory. I can't say that this is the most efficient way to do this because I really don't know. I know there are other ways that people do this. I think the times are pretty decent for this, but if if anybody else has some pointers or some tips, or would even like to share perhaps another method of how to do this, then I would definitely like to hear that. So thank you for watching, and I hope you enjoyed and get some use out of this. Thank you. Okay, we have our using statements. We got system diagnostics, and system IO. And diagnostics is going to give us timestamping. System IO is going to let me use the directory info object. Namespace is the directory example. And we have a main function and a tally file sizes function. This is the file size counter class. I'm using system collections generic, and system IO. The collections will give us the stack class to iterate through the Windows directory, and system.io for the directory info object. The name is the file size counter, and I have a few variables here. First, I have the root folder, which is the directory info object that gets passed into the class. I have a variable to hold the sum of all the file sizes, and I have the folder count and file count variables, which will keep track of how many folders and files I've successfully processed. I also have some error variables to keep track of various errors. That's security exceptions, directory not found, unauthorized access exceptions, and other errors. I have 4 methods in the class. I have a private sum file sizes, which does the work of calculating the file sizes. I have a public file size counter constructor, which is an empty constructor. I have a public tally file size, which takes the directory info object, and that's going to be the root folder that we pass into the class. And I also have a public print all stats, which puts the results of the variables that I just went over that collect the details about the performance. Now I'm going to walk through the logic of the program. The first 2 lines declares a new directory info object named directory. And this is going to be the directory info object that we pass into the class. And next, we're going to call the tally file sizes function, and we're going to pass that object into that function. Okay, I've sent the directory info object to the tally file sizes function. I'm going to go ahead and write out a line to the user telling them that I'm summing the file sizes for that directory. I'm going to declare and start a new stopwatch so that I can record how long the process takes. I'm going to declare a new file size counter, and I'm going to send that directory info object to the tally file size method. Okay, let's take a look at the tally file size method. The tally file sizes method sets up the variables. Now, if it's been used before, these numbers would be assigned some value. What we want to do is just make sure they're reset to 0 and that the root folder is set to the correct root folder that we're setting in. And then it's going to call the sum file sizes function to do the actual work. The sum file sizes method is the part that does the real work. We do some setup, we enter into a while loop, we iterate through the Windows directory, and finally we'll exit. Alright, let's look at the setup. We're going to go ahead and create a new stack of directory info objects called folder stack, and we're going to push our root folder onto the stack. We're going to create a temporary current folder variable, which is a directory info object. And we're going to create an array of directory info objects for the subdirectory lists in each folder that we process. And we're going to create an array of file info objects called current file list. Next, we're going to enter into the while loop if the folder stack has any contents. So we'll enter into the while loop, and we're going to go ahead and pop off the top of the stack. And the first run through, that's going to be the root folder. And we're going to save that to the current folder variable. The next part is the try catch block. In the try part, we're going to be doing the IO, and if that fails, then our catch blocks will catch whatever particular exception is thrown, or it may catch some unforeseen error. Alright, in the try block, we're going to be doing the input-output. And of course, what happens is sometimes you get some sort of an exception. It could be a security exception or a directory not found exception, or most commonly on my computer, it's an access denied exception. In this try block, I end up looking at each file that's in this list, and if any of them throw an exception, it's just going to exit the try block and it's going to go to the catch blocks. So if there were 9 good files in a list of 10, but the last one was inaccessible for some reason, then it's going to throw an error, and those 9 that were good will not be counted either. And that is not what you would typically want to be doing, but basically this is just an example of how you can use the stack to iterate through the Windows directory. Now, you could write this try block basically any way that you wanted to. It doesn't even have to just compute file sizes. It could be doing anything that you want. So let's look at the first 2 lines. What I do first is I get the directories and I get the files for the current folder, and I save that to our temporary variables. And next, this is a part where I access the file size for each file, and I add those onto the sum file sizes variable. And then next, I will go through the subdirectory list, and I will push each subdirectory onto the folder stack. That is going to be the next folders that we're working on when we go through the while loop again. Alright, now I'm going to increment my file count by the number of files that are in the list, and I'm going to increment the folder count by 1. So this last part is basically a way of giving some feedback to the user, and I'm basically just checking to see if my folder count is divisible by 250 evenly. And what that'll do is every 250 folders, the console will output a dot. So that way the user is aware that the program is still doing something and hasn't hung up, because some people have very big hard drives. Mine is not that large that I'm searching on. It's only 140 gigabytes or so. But for some people, I mean, this process could take quite a while. It could take a minute or 2 or something. So that's a way of giving some feedback to the user. Alright, that is the try catch block. And the catch blocks basically are just checking for security exceptions, directory not found exceptions, unauthorized access exceptions, or any other errors that it might find, and it increments the appropriate variables so that later, when I print out the stats, it can show how many of those errors were found. The last thing that happens in this function is to do basically a carriage return after all those dots that I printed, so that the next thing that I print out in the program doesn't end up on the same line as those dots. So I just do a console.writeLine, and then the function returns. So that is the end of the tally file size method, and now we will return back to the calling function, which was the tally file sizes function. Alright, we've returned to the tally file sizes function, and we're going to go ahead and stop the stopwatch and write out to the console the elapsed time. Next, we're going to call the printAllStats method and print out the statistics. This is the printAllStats method. It writes a couple of lines to the console and gives the stats, how many folders were accessed successfully, how many files were counted successfully, and the sum of the files in gigabytes, and the number of exceptions that were encountered. Okay, the next thing that we're going to do is write out to the console for the user to press enter when they wish to continue, and we'll do a read line to wait for their input. After they've decided to continue, we're just going to run the program a second time. On mine, I run it on the program files times 86. It's much smaller than the entire drive, and it only takes about 4 seconds on mine. So it's just a second run through. And then finally we do another console write line and ask them to press enter when they are ready to end the program, and a read line to wait for their input. After that, the program is done.